In this presentation, we're going to look at the joint distribution of random variables. So we have two random variables here, x and y. So consider the random variable x, taking the value x equal to 1 if a randomly selected person is a smoker, and x equal to 0 otherwise. This question actually has a health science application or sports science application or so on. The random variable y describes the amount of physical exercise per week that a person a randomly selected person will do. It could take the value 0, which is less than 1 hour per week, 1 for 1 to 2 hours, or 2, which means 2 or more hours per week of exercise. Okay, so we have three possible outcomes there of y: 0, 1, and 2. And this is the joint table there. The joint distribution of x and y is given by the joint probability function in the following table. So x equal to 0 and y equals 0, that the joint probability there is 0.2. Something we should check is this double check, is to check that they all add up to 1. 0.2 plus 0.1 gives us 0.3. 0.3 plus 0.1 gives us 0.4. And 0.25 and 0.05 gives us 0.30, and those would add up to 1. Just something to double check in your mind. I'm sort of putting a lot of emphasis on it, but just something to double check there. Okay. Likewise, you would sort of add up the row totals as well, and actually that's something you do as part of the question, and that should be 0.75 and 0.25. Okay. Now the random variable r, okay, not related to the programming language, it's a risk index. Okay, is calculated as 3 minus y squared times x plus 1. And this is used as a risk index for a particular heart disease. Okay, so calculate the... So is that... Okay, so essentially we're going to park that and go back to that later. Okay, so there's 4 questions here. And what we'll do is look at the first 2, and then which are related to the x and y, and then the second 2, which is related to r. So calculate the probability that a randomly selected person does more than 2 hours per week. Okay, so that is a probability of y equal to 2. Okay, and determine whether or not x and y are independent, justifying your answer. Okay, after that, what we'll do is look at r, determine the joint the probability function of r, and calculate the expectation, which is to say the expected value. Okay, this is a sort of straightforward enough discrete random variable question, really. So part A, essentially what I've done there is just actually sort of, this is sort of formalization or tidying up what I've done there. Just checking the answers there, but we find that the probability of y equal to the marginal probability is 0.3. The totals here, which are to say these totals here, well, not the total there, not the grand total 1, not that one really, but they are called the marginal probabilities. And really, in a joint random variable question like this, that you should probably tot them up very quickly. In fact, we did just to double check, but they're probably going to be part of the question, so you should look at them quickly. So anyway, the answer there is 0.3. Okay, that's really all we have to do. Now, what we have to see here is if the x and y are independent. Now, I'm going to pick on one particular pairing here. So I'm going to sort of look at that one there. No reason I can go for any of the other 6, but essentially what I'm going to do here is look at x equals 0 and y equal to 2. Okay, and I'm going to sort of base my answer on that. So pick x equals 0 and y equal to 2, and just to say this is one of the 6. Any of the others can be just as good. Okay, so the probability of x equal to 0 and the probability of y equal to 2 is 0.3, 0.75 and 0.3. Again, those are the marginal probabilities there. Okay, so the joint probability is 0.25. Okay. Okay, so that's the joint probability of x equal to 0 and y equal to 2. Okay, we'll call that the joint probability. And by the way, that's actually just determined from the question, okay, or the tables. Okay, so that's something we're given. That's just actually reading the tables. Okay, now independent events. So this is the independent event formula. We want to see if the probability of x equal to 0 times the probability of y equal to 2 would that give us the same value as this joint probability? Okay, and the answer here is 0.3 times 0.75, which is 0.225. Okay, so they're not equal to each other. Okay, 0.25 is not equal to 0.225. Okay, so we don't have independent events here. Okay, they're not independent. So essentially, just to be absolutely clear what I'm saying, this expression here and this expression here do not equal to each other numerically. Okay, now that sort of answers the question for us. Okay, but what might happen there is that you might actually by accident get that particular answer. Okay, so what you should do if it turned out that they did equal to each other, okay, the best thing to do is just go look for a second one. Okay, because just double check with a second pairing. Okay, I'm not going to do it here, but that would be the case. If you did get one where they did happen to equal each other, that might be just a sort of mathematical accident, so to speak. So it's best to double check with a second pairing. I'm not going to do that. In this case, it's unnecessary, but you know, just double check your answers with a second pairing in case the first one gives you seems that you do have two independent events. Okay. Now, what we're going to do here is calculate R. So let's just remind ourselves what R is. R is equal to 3 minus y to be squared times x plus 1. Okay. So these are the possible pairs of values that we have here. Now you don't really have to go into this level of detail. I'm just trying to make it as simple as possible to read on a screen. Okay, so this is just a re-expression of the table. Okay, and essentially I'm setting it up in small pieces. So essentially what I'm doing here is 3 minus y, which is 3 minus 0. 3 minus 1 gives us 2. 3 minus 2 gives us 1, and so on. So 3 minus y would be 3 to 1 and 3 to 1. So when we square that, we get 9 times 4 times 1, and 9, 4 and 1, 9, 4 and 1. Okay. X plus 1 is simply this value plus 1. Okay, just for the whole way through. So essentially you got 1 and 2. Okay. So essentially when we multiply it out, the possible outcomes for R are 9, 4, 1, 18, 8, and 2. So there's six individual possible outcomes based on this scenario for R. Okay. Now, so essentially what we do here is set up the table. Okay. Just watch out. Sometimes you might get two scenarios where you get the same outcome. You know, for example, two different pairings of X and Y possibly could give you the same pairing of R. So in that case, what you do is combine the probabilities. But in this case, we have 6 scenarios, and each of those 6 scenarios gives us one individual possible value of R. So the probability function of R is essentially using these values here and these values here. Just for the sake of simplicity, or sake of neatness, I just went in ascending order of R there. Okay, so small r here means the possible value of R. So the probability of R equal small r means probability of R equal to 1. So essentially, where do these probabilities come from? It's essentially these probabilities just in a new order. Okay. Alright, in ascending order of R. Okay. 1, 2, 4, 8, 9, and 18. Okay. So that's just straightforward enough. Really, it's just a little bit of number crunching, and it sort of helps to actually just show your answers. Finally, the expected value of R is the sum of each individual observation of R times the probability of that. Okay. So 0.15 or 0.25 times 1 plus 0.05 times 2, and so on. So essentially you should get an answer of 5.95. So this is just an expected value there. Okay, this is the expectation of R, the expected value of R, the mean of R essentially. So hopefully that won't put too much pressure on you, that calculation there. I'll just move that into shot there just in case it's offside. Okay, we'll leave it there.